Hey everyone, welcome back to the channel. Today we're diving into something huge. We're talking about the sun. I'm going to explain everything you need to know about the sun. Let's break it all down in a way that anyone can understand. Let's get into it. How was the sun formed? To understand how the sun works, we need to go way back, around 4.6 billion years ago. Back then, there was a huge cloud of gas and dust floating in space. Those gases are mostly hydrogen. The huge cloud of gas is called a nebula. At some point, something triggered that cloud to start collapsing in on itself. Maybe the explosion of a nearby star. As the gas clumped together, gravity pulled more and more material toward the center. The pressure and temperature rose, and then nuclear fusion began. That's when the sun was born. The leftover gas and dust became the planets, moons, and everything else in our solar system. How does the sun work? The sun looks like just a bright ball of fire in the sky, but it's actually a massive nuclear reactor. At the core of the sun, tiny atoms of hydrogen are constantly being fused together to form helium. This process is called nuclear fusion, and it releases an insane amount of energy in the form of light and heat. Let's explain it a bit more, because after all, that's why you clicked on this video. At the very center of the sun, in its core, conditions are extreme. The temperature reaches around 15 million degrees Celsius, and the pressure is unimaginably high because of all the layers of gas pressing down from above. This is the sun compared to Earth, so we can only imagine how high the pressure must be in the sun's core. These intense conditions cause hydrogen atoms, or more precisely, protons, to move at incredibly high speeds. Now, normally, protons repel each other because they both have a positive charge. But inside the sun's core, they're moving so fast and are so tightly packed that some of them crash into each other with enough force to overcome this repulsion. When that happens, fusion begins. The main type of fusion in the sun is called the proton-proton chain reaction, and it happens in several steps. First, two protons collide. During this collision, one of the protons is transformed into a neutron, a process that also releases a positron, which is a positively charged electron, and a neutrino, a nearly massless particle that escapes the sun at nearly the speed of light. The result is a new atomic nucleus called deuterium, which is one proton and one neutron bound together. Next, this deuterium nucleus collides with another proton. When they fuse, they create a nucleus of helium-3, which has two protons and one neutron. This reaction also releases a gamma ray, a high-energy photon that will eventually become part of the sunlight we receive on Earth. Then, two helium-3 nuclei collide. This forms a helium-4 nucleus, which contains two protons and two neutrons, the same helium that fills balloons here on Earth. In this step, two extra protons are also released, which can go back into the fusion cycle. But the sun doesn't just produce helium. During fusion, especially in larger or older stars, new heavier elements can start to form as well. In the sun, most of the fusion stops at helium, but in later stages of its life, when the core gets hotter and more compressed, it can start creating elements like carbon, nitrogen, and oxygen through further fusion reactions. These elements are the building blocks of life. Even heavier elements, like iron, gold, and uranium, aren't made in the sun, but are formed in the explosive deaths of massive stars. Almost every atom in your body, carbon in your cells, calcium in your bones, oxygen in your lungs, was made long ago in the heart of a star. We are, quite literally, made of stardust. These thoughts keep you up at night. Now here's the key point. If you add up the mass of the four original protons and compare it to the mass of the final helium nucleus, you'll notice something interesting. The helium nucleus weighs just a tiny bit less. That missing mass hasn't disappeared, it's been converted into energy. This is where Einstein's famous equation comes in. E equals mc squared. Energy equals mass times the speed of light squared. And since the speed of light is such a huge number, even a small amount of lost mass becomes an enormous amount of energy. That energy radiates outward through the layers of the sun, a journey that can take thousands to millions of years, until it reaches the surface and escapes into space as heat and light. Nuclear fusion happens constantly. Every single second, the sun fuses about 600 million tons of hydrogen into helium. And in that same second, about 4 million tons of mass are turned into pure energy. That energy is what powers the sun, lights up our sky, warms the earth, drives our weather, and makes life possible. Without fusion, the sun wouldn't shine, and without the sun, there would be no life on Earth. So, at the heart of everything we know, there's this cosmic engine, a self-sustaining fusion reaction that has been burning for billions of years and will continue for billions more. Now here's the big question. Will the sun ever die? Yes. In about 5 billion years, the sun will run out of hydrogen in its core. When that happens, it'll swell up into a massive red giant, possibly swallowing Mercury, Venus, and maybe even Earth. After that, it'll shed its outer layers, forming a beautiful planetary nebula, a colorful cloud of gas. What's left behind is the sun's hot, dense core, now called a white dwarf. That white dwarf will cool slowly over billions of years until it becomes cold and dark, the sun's final form. If you enjoyed this video, give it a like, hit that subscribe button, and let me know in the comments what topic you want me to cover next. Thanks for watching, and see you next time.